I'm going to start with that, Discord on chain. Just real quick about me. This is, if you see me on GitHub, this is what you're going to see. I have all these titles: CTO, co-founder, software engineer. Just means like I'm doing everything all day long. Like other people say like full stack engineer, so I'm just fixing everything, the front end and the back end. Working on the thing called Diode. I don't want to shill it too much, but it's actually also why I'm in this topic, and we do build like a Discord on chain, so we're gonna see a couple of the smart contracts and the ideas and problems we have based on that. And I'm also an Elixir fanboy, so there is like this Elixir is a niche functional language. I'm running also the Meetup there, so it's completely unrelated to blockchain, but it's amazing, just in case you want to check out. So what we wanted to talk about is the introduction, the motivation a bit, and the social graphs on chain, like how can we store them, then how do we define groups and roles, and then we're going to talk a bit about recovery, like what does it actually mean, what are the problems, multi-devices, and also privacy. And that's basically where I want to end up and talk about that a bit. And I'm really curious at connecting with you people, especially if you work in some of these areas or are researching in these areas, because there's a ton of open problems here. So with that said, actually this talk has been triggered by Iskander over there, who presented in January this Anon Club, where he presented like this kind of different membership systems that we have, whether it's an airdrop or a chat group, so that's here we are today, or voting or mixes. All of these have the problem of anonymity or like privacy. And he presented like one solution that they're working on with ZK Snarks. And so proof of membership and on chat groups, that was like, oh, that's me. Like that's like what we want to talk about. So first thing is members. This might be, if this is way too small for you guys on the back, we can try to make it a little bit bigger maybe, but I think, so we want to talk about members. So you know this, you log into Discord, you see the member list, and you see the names. So how do we do that in a smart contract? This is going to be pretty technical, so I just want to go through some smart contract details. I'm now zooming in on this slide so you guys can see there, back there. This is like the simplest thing in a Solidity contract. We have a simple group, we have a set. This is already where like on Solidity, unfortunately, there's no native set. So in Open Zeppelin contract, there's an enumerable set. There's different set implementations. You could also just use a hash alone, but the problem is if you just use a hash to know if somebody's a member or not, you cannot iterate it, right? And so back to the screen, it's actually really nice to be able to iterate it in an app, to say like, oh, there's 6 members, and we can show all of them, not only check is he member or not, but actually go over them. So, but this is not enough, because so far we just have a group, but we can actually not change any permissions. So we want to add and remove more friends to our group, right? So we need a couple of more functions on this. So first thing is we need some roles. In Discord, we see them actually highlighted in different colors. So we can have somebody who's an owner, an admin, he can add and remove people, but probably not the one who created my chat. And then we have normal members. Maybe we have bots who do things in our group that have even lower permissions. And we have like the 0 permission here. Really simple samples. So this is all sample code that I created here. And basically took our contracts, cleaned them up for presentation, removed everything that is like the nitty-gritty details of our specific implementation. So it's a bit easier to understand. So what we're getting in addition are roles. So we have the members, but now we're adding roles. And on top of these roles, we define some actions that they can do. Again, I think this is still too small in the back there, but basically we have add member. So if you're an admin, so that's like if you're an admin, you can add a normal member, right? This is kind of the permission system that we want to have. We also have like remove self. That's very, very common in most of these group systems. So only admins can usually add or remove somebody, but everyone can remove themselves. Like you always have the ability to leave a group, right? So there's like, that's smart contract function. And the owner, he can also elect admins, he can promote admins, he can demote them back to normal members and do change all of that. One of the challenges when doing with this is that there's unfortunately very few EIPs or ERCs that standardize these things. So Open Zeppelin, for example, again, they have this role-based access, but there is no EIP on that. So it's not a standard that everyone implements. So everyone is kind of driving their own implementation of like, how do we manage roles? How do we manage role membership and group membership? I'm gonna come to like the challenges back. So next problem is, I'm gonna zoom out here real quick so we can see the whole slide. Multiple devices. So actually, what happens here is that most people actually have not only a single device that they work on, but they have a phone and a computer, at least two. And they want to be able to join Discord from both of these devices. And so there's like the bad idea number one is we just take the same private key they have on this device and we copy it over to that device, right? And that's the easiest, and it's the same identity, and we know like it's the same person. The problem with that kind of first bad idea is when you lose any of these devices, that single key that you have is gone, right? It's now out in the wild, and there's no way to recover or to delist that device as being lost or do anything like that. It's like game over. So a little bit better idea is we do one key per device. So actually when you do end-to-end encrypted applications like a Signal, you will see that as well, or WhatsApp doing it as well. Every device you have has its own identity, has its own key that it's using. So we have one key per device, but we have like a contract in the system that is used by all of them together to represent the identity of that user. I've put like a EOA, some term that you often see in like Ethereum speak. I don't know how many are aware of that. Like I always have to look it up, but it's externally owned account. So that's a real wallet compared to like a smart contract, like in this case is a multi-sig contract. So this is the idea again. Like the bad idea one is we just copy the same key, like the same private key to two devices. And let's say we are Anna in our group that was like the first in the initial picture that we had, then both devices are the same person. The better idea here is like with an abstraction step in between. So we have like a multi-sig contract. We call it here the identity. Both of these devices are listed in that identity. And then that identity is part of our group. So that's part of like our Discord group, for example. And we're jumping here to code. So it's not really a multi-sig because it's more like a one of many. So it's kind of the opposite of a multi-sig. You have 5 devices. Any of these 5 devices can do whatever is needed in the identity. And what is needed in the identity, so we add like a identity contract here. It needs to have an initial device, an initial device owner, that's the starting device, and that device has the ability to add other devices. So again, you know this probably from WhatsApp. You link your first device with a second device, you link them together, which means like the first device kind of authenticates the second device as this device can also impersonate me. I'm also using that. And so this way we're doing it on a smart contract. So this add device can only be called by another device. So one device has the ability to add more and more devices. And most importantly, we want to, let's say we are an admin of this group. And so one of the functions we want to call is like add and remove people inside that Discord group, or turn a moderator into an admin or an admin back to a normal member. These kind of operations which are transactions. So this has like a multi-sig that you see in Gnosis, like this submit transaction that is then an external call under this identity and then allows you to impersonate really that identity. Now this works pretty nice, but it creates another problem here. Let me see whether I can go back. So we solved that the linking. Let me check whether we talked about everything. Every device can submit. We don't have this master key, and the multi-sig, we talked about that. So what happens when you lose your phone, right? So if you lose your phone, we wanted to talk about that. There's this problem right now that with this device that you lost, it can still add new devices to your identity, right? So in theory, if an attacker gets hold of your device and unlucky enough, he's able to unlock it, you could be trying on your device to remove linked devices, and he could at the same time, in the same speed, try to add devices, right? And then you have like this race where the question is who's going to be faster, you or him? And in the worst case, he's removing all of your devices, and then he locked you out. So we thought of something like, how can we recover from that? We need something like a protector role, like something that is maybe a hardware wallet, like a ledger, or like a piece of paper that you have printed out that you can use to recover from here. I'm gonna zoom in. So it's like this typical piece of paper with like the backup words. Found this on the internet. I don't think it's a real account. So it's like this is very similar to the previous contract. We just have added like a protector, and so that's now the initial member is a protector, and the protector has one feature. He can turn the identity into protected mode, which means only he can make changes, right? So the idea is your phone gets lost or gets stolen, maybe if you're on a crypto event, and then you can enable protection on this identity with your backup, with your hardware wallet, so that nobody else can add more identities. So we stop this race from happening, and then you can clean up. You remove the phone, you remove any other suspicious linked devices that you actually didn't add. And then you can go back to like the original state, you can disable protection, you can start using it normal again. So kind of going through real world problems that we had to deal with and our customers were asking us. I'm trying to be quick with this. So social graph, that's like the thing we wanted to talk about. So who doesn't know what the social graph is? Anyone? Like, it seems, I think it's pretty well known. But just to go through this picture really quick, so you might be member of 3 Discord communities, and now because everything is on chain, somebody scanning the chain can actually see, well, there's all of these members, but actually 3 members are also part of this community. And now I can get a pretty good picture of like, what are your interests probably, who are your friends probably, and start doing really nasty stuff. It can be as simple as these nasty Telegram bots that sometimes you see they join all the same groups you're part of, and you wonder like, how do they do that? Like, why do you see plopping up all this name in like 5 different groups that you're a member of? So they can start following you, or they can start like social engineering against you, right? So you're like, oh, you have a friend. Maybe we cannot attack you directly, but maybe we can get into your friend first and then impersonate your friend and then do stuff like that, right? So there's a lot of bad things you can do once you get into the social graph. So generally we want to protect the social graph, protect against those people scanning it. So there's like 3 ways I have identified so far, and that we're doing right now the first one because it's the dumbest and like the way you can exceed this. We tell our customers, for whom it's really important, you create multiple profiles. You actually you don't join like with the same profile 15 Discord groups. You create different profiles on chain, and you keep them separated this way. So you have completely independent wallets, you have completely independent identity contracts on chain, and you do it this way. There's a problem with like, how do you manage then recovery? Because it can't be the same address everywhere. And also, what about time correlation? So imagine you have an identity, it has like 4 devices, maybe an iPad and a computer and a phone and so on, and now you add one more device, right? But now this one more device that you link to your fleet of devices is going to be added to all these copy identities, like your multiple profiles that you have. Because of course you want on this new device access to all your groups. And so that means it's not transactions going to the same addresses, but they're happening at the same time. Now, this happening 2 or 3 or 4 times can be enough for an attacker to deduct, oh, this is actually the same person. So Tornado Cash, for example, has a very similar problem. Like if Tornado Cash is like totally anonymous, but if you send it $100 million US, and then basically you deduct immediately $100 million US, even though the addresses are random, everyone looking at it knows like, oh yeah, this is the same guy. Like this is how they found that North Korea is deducting through Tornado Cash, because they didn't do it very smart. So snarks, again, I talked about that. There's some really, I just want to put that out here. There's like this Noria language. I don't know if you ever implemented snarks, like Tornado Cache. Like that's really nice and makes it super easy. So I'm just putting the link here. And there's some of that, these enablers already in Ethereum, right? So there's like some of, this is super small, you cannot read this. Even if I zoom in, I think you still cannot read this. But some of the enablers are there as precompiles, and so you can do certain ZK snarks today. There's all these alt BN 128. So there's a bit of tooling around that and doing basically zero knowledge proofs, like membership proofs, for example, you can do with that. But the problem is like some of the things we just talked about, like we want to have multiple devices, we want it to be enumerated, it all becomes very, very gas expensive to like to the degree of non-feasible. Like with Tornado Cache, it's fine if you transfer like 10K US dollar. It's fine if you pay $50 in transaction cost. If you add a member to your Discord group, it's not fine to pay $50. You know, like we have to be very gas efficient. The other thing, it makes it very complicated just from the amount of engineering you need to do in the Solidity contracts to do it. So, and that means you can have errors easier. There's way more code you have to write, and it's much harder to understand what's happening actually. So this is a pretty big problem with snarks so far for us. And then there's like I don't know, another cheap out. I don't know who was on East Denver, but there's quite a couple of these EVM engines now out there that say they're privacy EVMs. So they actually protect the EVM state. So Oasis is one, Phoenix is one, I think Secret Protocol, somehow they're the same as Phoenix, I'm not quite sure on their separation. So have these EVMs that keep state private. There's still a problem with like the sender and the receiver. So if you don't encrypt that, then still people can see on chain what's happening there. How am I doing in time here?
Still have 5 minutes.
That's great. And with that, actually I'm coming to the end here. So really, we talked about these challenges. A really big one is that there's not enough ERCs in the EIP. So again, like even though we built this, there's not a lot of building on top of each other, which is really, really sad. I would hope, maybe if you guys are curious, I would really hope to I would love to work with somebody together on standards. If there's somebody doing similar projects, right? Then I think it's much more likely to be successful. The only one, like even though it's so fundamental, I feel like memberships and groups and permissions, there's very little ERCs around that and EIPs. Social graph privacy, I think, is an unsolved problem. Like everyone talks about it, but there's not like the silver bullet yet. If you know something, please let me know again. And the paying for transactions is a bit of pain, but I think there are some solutions now. We use some solutions, so at least that is good. It also has there's an anonymity aspect to it, right? If you want to hide the sender address, you have to have somebody else who's paying the gas fees for you. But it seems to be more or less solved. And then recovery methods. I presented what we do, but there's a lot around like social recovery. Like that whole topic is also not very well covered, if at all, by ERCs or EIPs. There's no golden formula out there. So again, if you're connected to like the project that has totally solved this or that, like I'm really happy to talk with you guys. And this is really what we have done so far and how we have approached it. Yeah.
Yeah, I'm curious. Like, was the beginning? Are you building on Ethereum, like on the main?
We started out on like our own application chain that was EVM compatible. Because we didn't solve the gas problem initially, like who's paying for it. So we did like what everyone did like 4 years ago. We started on an application chain that is basically gas free. And we changed that and going to other EVM compatible chains. And we want to get rid of our L1 because it's just like a maintenance hell. And we're going to like a Moonbeam right now. And then afterwards we're going to a ton more.
Yeah, I'm asking because as a solution to this privacy issue that the blockchain might be indexed, you mentioned that you like create multiple identities on chain, and it's like gas consuming operations, heavily gas consuming. So I was curious, how do you solve it from a user perspective? I mean,
yeah, like running on Ethereum mainnet is not cost efficient, right? So, so it must be an L2 right now. So
no, I'm also saying that if you're trying to create multiple identities, you still try to create multiple identities from different wallets. So you first have to top up these wallets with some amount of native tokens in order to execute.
Exactly. Yeah.
So, like, do you have some kind of paymaster based?
Yeah. So that's what I'm saying. Like this is actually like you have the paymaster. The different like many of like the alternative chains have their own solutions to that. In Moonbeam, for example, they have a construct called a call permit, but it does effectively the same. You let somebody else pay, which solves like you need some construct, whether it's 4337 or different, but you always need that. Not only for the single account, multi-account problem, but just to have like a smooth experience on like a normal Discord user would expect from Discord. You want to add a member, and you don't want like a pop-up with a signature, and you don't know what's like that. This kind of experience doesn't work too well. If that makes sense.
Yeah. I just wanted to mention, if you're like relying on some Moonbeam like features, it's not that then transferable to other chains like easily. So like because some features like Moonbeam might not be supported by other Moonbeam.
Yeah, it doesn't affect the smart contracts too much. I mean, in the sample smart contracts, these are just sample smart contracts, and I made it really simple. I just used message sender, right? If you use 4337, you don't do that. You use like the underscore message sender, because that's actually overridable. But this is just sample contracts I wanted to make here to make sure. Actually, the difference to support Moonbeam or one of the other alternatives or 4337 is not big. Actually, the impact on the smart contract is really small.
Actually, with 4337, there is no need to use underscore message sender. It's with method transaction actually is the case. With 4337, it's like with a regular message sender, it will be supportable. So, like the role of the user account is handled by the smart contract itself. So, like it should be supportable with 4337 without any changes to the smart contract.
Let's talk about that, because then maybe your understanding is different than mine. But let's talk about it. Have you worked with that? Yeah. Let's talk about this then. I like it. Any more questions on this? Anyone working on anything with groups or memberships? I see one.
I mean, I haven't solved the APs regarding the memberships, but there is definitely a draft AP regarding the DAOs. And it might be applicable to the case of the groups. So there is also members.
Yeah. There's some on the DAOs, but even on the DAOs, I'm really sad. Like you would think, like DAO being such a common concept, that there would be more consolidation already, but there's not.
Yeah, that's why it's a draft of AP.
Yeah, exactly. It's a draft, and there's so many DAOs out there, but like not many follow any standards. And also, like DAOs have a different prompt set. Often, like being able to enumerate all members is not necessarily needed in a DAO. And also, DAOs often want the opposite in terms of privacy. Like they actually want to say, like, we have these like famous members, and you can look them up by their ENS names, right? And this is truly this guy, which is really opposite from like you have these 15 chat groups, and you don't want to tell the world what you're a member of. But yeah, I would hope there's more standardization. Thank you so much. If there's no further questions, then